So I am Jay, and I will be going to discuss to you a new topic in integral calculus, that is integration of trigonometric functions. But before that, we have to review some basic knowledge in trigonometry, and that is trigonometric identities. Later on, we will be going to use this formula or those trigonometric identities in dealing with the integration of trigonometric functions. So I know you have already encountered trigonometric functions in your trigonometric class. And the most basic one, the most basic trigonometric identity is the right triangle. Now we have trigonometric identity for sine theta is equal to 1 over cos secant theta, right? We have also cosine theta is equal to 1 over secant theta. We have also tangent theta is equivalent to 1 over cotangent theta, or this just basically equals 2 sine theta over cosine theta. And we have also in trigonometric identity for double angle, for half angle, and the unit circle. So for unit circle, we have sine squared theta plus cosine squared theta is equal to 1. We have tan squared theta plus 1 is equal to secant squared theta. Okay, so you have to familiarize, or you have to memorize all these trigonometric formula, because this will help us in dealing with functions that involves trigonometric transformation later on. Okay, because as what I have encountered, a lot of students are having difficulties in integrating trigonometric functions um, because they are not familiar with all these trigonometric formula, trigonometric identities. So therefore, it is very necessary and helpful that you put this formula in your head, no, and memorize this formula. And also, you have to solve a lot of problem with different cases. It is just a matter of practice. I think integration of trigonometric function is one of the most difficult topic in integral calculus, because um, it doesn't have a specific rule. No, you have to have a good strategy. No, it is just a matter of trial and error. So therefore, practicing is such a big help, in dealing with this kind, in dealing with problem that involves trigonometric function. So actually, I have prepared a new uh, example. No, so I have here the integration of sine squared 4x cosine squared 4x dx. So upon looking at the function, we can conclude that we cannot actually use directly the basic integration rule that we have, like the power rule, or the basic integration of trigonometric um, function that we have, no. So all we need to do here is to transform this function into a function that can be integrated. Okay, so the first thing that we need to do here is to um, factor out, or to take squared outside of the function. That is the integration of sine 4x cosine 4x squared dx. And sine 4x cosine 4x is actually um, a double angle, or actually a derived from a double angle trigonometric identity, right? We have, if you can recall, we have the double angle sine 2 theta is equal to 2 sine theta cosine theta. However, guys, in this function, we don't have a coefficient of 2, but in a given trigonometric identity, it has a 2 coefficient. So what we need to do here is um, to eliminate the function 2. So how are you going to eliminate 2 here? So you have to divide both sides of the equation by 2, or multiply both sides by 1/2. So we can rewrite the identity as sine theta cosine theta is equal to sine 2 theta over 2. So we can now use this equation as a value of this function. Okay, So we can rewrite this, but in this case, we can actually say that theta is equal to 4x, right? So we can say that sine, integration of sine, when we have 2 times 4x over 2. But take note, the function is raised to 2 in the original function. Therefore, we have to raise it to 2 as well, or square the function as well. So we can directly, by further evaluation, we can say that it is sine squared, the angle now is 8x over 4, okay, dx. However, we still don't have a integration formula for sine squared 8x. We don't have an integration rule. So therefore, we need to find other trigonometric identities that can be used for this one sine squared 8x. So if you remember your trigonometric identity, we have sine squared theta is basically equal to 1 minus cosine 2 theta over 2. In this case, our theta is equal to 8x. So we can actually use this trigonometric identity. So we factor out 1/4 outside of the integration. Then because it is constant, we can actually take out constant outside of the integration sign. Then we have sine squared 8x dx, or it is equal to 1/4 1 minus cosine of 2 times 8x over 2 dx. Then we can separate, or we can divide this function into two terms. So we integrate it separately. That is equal to 1 over 8 integration of dx minus 1 over 8 the integration of cosine 16x dx. Okay, so now we can apply the integration rule that we already have discussed. That is the integration of r dx is equal to r x plus c, right? And the integration of cosine u du is equal to sine u plus c. You can remember. So therefore, we can say that it is 1 over 8x minus, but in this case, our u is equal to 16x. So therefore, our du is 16 dx. So if this is our du should be 16 dx. So we'll multiply 16 and we multiply its reciprocal outside of the integration. That is 1 over 16 dx. So why we need to multiply 1 over 16? In order to balance the equation. As much as possible, we should not multiply or we should not change the value of our equation. So in the case that we are going to have a multiplier, then we need to multiply it. We need to have a multiplier reciprocal to it, to the number, okay, because as if that we are multiplying 1 to the equation. Okay, 16 times 1 over 16 is equal to 1. So as if that we are doing nothing to the equation, or we did not do anything sa equation. Okay, so 1 over 16 times 1 over 8 is equivalent to 1 over 1 to 8 integration of cosine 16x, that is equivalent to sine 16x plus c. So this is the integration of the function sine squared 4x cosine squared 4x dx.